All right, if you're gearing up for your GCSE chemistry exams, you are in exactly the right place. We're going to break down AQA's required practical 4, all about temperature changes, and we'll focus on everything you need to know to walk into that exam feeling totally confident.
So here's our game plan. First up, we'll get straight on what this practical is even for. Then we'll cover the science behind it, walk through the actual method, look at how to make sense of your results, and finish up with the most important bit, how to absolutely smash the exam questions. Let's do this.
Okay, so what's the big idea with this experiment? Seriously, before you even think about touching a beaker, you've got to know what you're actually trying to find out.
And here it is, the official line straight from AQA. The whole point is to investigate the variables that affect temperature changes in reacting solutions. In normal English, we're just mixing stuff together and measuring how the temperature changes. That's it.
Now, in the exam, they could ask you about any of these types of reactions. Maybe an acid with a metal, or a classic neutralization reaction. But you know what? They all have one thing in common. They all cause some kind of energy change that we can track with a thermometer. So, why does the temperature actually change? Well, this all comes down to two of the most important keywords for this entire topic: exothermic and endothermic. Every single reaction is one or the other.
It's all about which way the energy is going. For an exothermic reaction, think exit. Energy exits the reaction and goes out into the surroundings, so the temperature goes up. For an endothermic reaction, think enter. Energy has to enter the reaction from the surroundings, which makes them cooler, so the temperature goes down. That is the absolute key difference.
We can even picture this in a reaction profile diagram. See? For exothermic, the reactants up top have more energy locked away than the products down below. That difference in energy is what gets released as heat. And that little hump at the start, that's just the activation energy, the small push it needs to get going.
And for endothermic, well, it's the complete opposite. The reactants start low, with less energy than the products. So to make those higher energy products, the reaction has to suck in energy from its surroundings. And that's exactly why things get colder.
Okay, that's the science bit done. Now, how do we actually do this in the lab? Getting marks on method questions is all about being clear and knowing the right steps.
Here is a perfect, simple method. First, notice the polystyrene cup. That's a big deal. It's an insulator which helps stop heat escaping. So, you measure your solution, pop it into cup, and take the starting temperature. Then, you add your other reactant, give it a stir so it all mixes properly, and keep your eye on that thermometer. You're looking for the highest temperature it reaches for exothermic or the lowest for endothermic. And the last step? Simple maths. Just find the difference.
Right. This table is absolutely crucial for the exam. Seriously, your independent variable is the one thing you change on purpose, like maybe trying different metals. The dependent variable is what you measure, and for this practical, it's always the temperature change. And finally, your control variables are everything you have to keep the same to make it a fair test, like the volume of the acid. You have to know these three inside out.
Okay, so you've done the experiment, you've written down your numbers. So what? What do they actually tell you? The next skill is turning that raw data into a real scientific conclusion.
Just take a look at this simple results table. For that first reaction, the temperature jumped up by a whopping 14.5 degrees, but in the second one, it actually dropped by 3.5 degrees. See those little plus and minus signs? They're super important. So quick question for you. Based on what we've just talked about, which one is which? Well, reaction A, with that positive temperature change, has to be the exothermic one. And reaction B, where the temperature went down, that's got to be our endothermic one. It's as simple as that.
But hang on, how do we know our results are any good? AQA is very clear about this. An accurate measurement is one that's close to the true value. The thing is, in a school lab, it's really easy for little errors to sneak in.
And here are the usual suspects. The number one biggest source of error always is heat escaping to the surroundings. Even with that polystyrene cup, some energy gets away, which means your temperature change will look smaller than it really is. Other problems could be misreading the thermometer, not stirring enough, or being a bit sloppy when measuring your liquids. Knowing these is key for any evaluation question.
Okay, we're on the home stretch. Let's pull all of this together and focus on what the examiners are really looking for. This is how you turn what you know into actual marks on the paper.
AQA is actually assessing these specific skills. AT 1 and 3 are about using your gear correctly and writing down what you see. AT5 is all about measuring that temperature change properly, and AT6 is just about being safe when you mix the chemicals. When you describe your method clearly in an exam, you're proving you have these skills.
And this brings us back to probably the most important rule in all of science. For a valid conclusion, you must control your variables. If you're testing different acids, you have to use the exact same volume and concentration for each one. If you don't, you'll have no idea if the result was because of the acid or because you just used more of it. It's the whole point of a fair test.
So, I'm going to leave you with a classic exam-style question to think about. We know that heat loss is the biggest problem, right? So how could you improve this experiment to reduce it? What could you do to that polystyrene cup to make it even better at keeping the heat in? Answering questions like this is the absolute best revision you can do. Good luck!